Greetings and welcome to the New Mexico Collaborative Community's presentation on early counting and addition. The intended audience for this presentation is kinder and first grade teachers. If you work with older students, you may find the information useful to help you understand why some of your students may struggle to make progress with what you think of as uncomplicated math ideas. In this session, we will consider how to support young learners as they make the transition from counting collections to conceptualizing the operation of addition. I want to begin by introducing you to the stages of early arithmetic learning. The educator and researcher Les Steffi did extensive work with children in the 1980s, and through that work, he identified a series of conceptual stages that all children go through as they come to understand quantity and then formalize that understanding as they make conceptual sense of addition and subtraction. The first stage, perceptual counting, is one we are all familiar with. This is when students develop the skills and concepts needed to accurately count collections of objects. The second stage, figurative counting, is less familiar. We will explore this stage during this session. At a certain point, students come to realize that they can begin with the number in the first collection and count on from there to determine the total when a second collection is added. This marks a significant reorganization in a student's understanding. We will come back to this stage during the presentation to think more about what it means for a student to develop counting on strategies. Finally, students come to realize that they can use non-counting strategies to add and subtract. It is at this point that we would say that a student has developed additive reasoning. This stage, though interesting, will not be addressed in this session on early counting and addition. We can determine whether a student has developed perceptual counting by posing a task where they have to count collections of objects. In this case, the task is, there are 9 red counters and 5 blue counters. How many counters are there altogether? A student who can accurately complete this task and tell you that there are 14 counters can be said to be at the perceptual stage. Once a student has become good at counting visible collections, we can give the same tasks using hidden counters and ask the student to solve the problem without seeing the counters. Students who can tell you that there are 9 and then count up 5 counts can be said to be at the counting on stage. The important shift in the student's understanding is how they are thinking about the first collection. They understand that when they say 9, they are referring to all of the counters in that set. Steffi used the term numerical composite to identify this new way of thinking and referring to a collection. A student who can use one number to name a collection and count on to add additional objects is said to have developed the concept of a numerical composite. This thinking represents a significant reorganization in a child's understanding of quantity. In between perceptual counting and counting on, Steffi identified the stage that he calls figurative counting. This is what we will focus on in this session. What does it look like? Why is it such an important stage? And how can we support students whose counting is perceptual to shift to a more advanced stage of counting? First, let's consider a typical sequence of instruction for our young students in kinder and first grade. Once a child becomes proficient at counting 9 items and 5 more items and naming the total as 14, instruction tends to shift to showing the student how to record their actions using symbolic notation. We ask young learners to progress from a very concrete model for 9 and 5 more to a very abstract representation of that same idea. Because we can easily see how the two representations are related, we assume that students will easily make that connection as well. However, this is a big jump for many young children and can become a source of confusion if the instruction continues to move at such a quick pace. Steffi observed that as students become good at perceptual counting, he could conceal the counters. He noticed that students begin to realize that they can count the objects that are concealed even though they can't see them. However, the counting always begins at 1 at this stage because the student has not yet developed the concept of a numerical composite. The student will count out the number of items under the first cover and then move on to the second cover, continuing the counting sequence to determine the total number of hidden counters. Students who are at this figurative stage are working to solve a problem of how many you have when there are 9 and 5 more. They are making sense of a challenging task on their own, discovering that they can do something a little more sophisticated than what they used to do. These are the hallmarks of a good math problem. So the important question for teachers of young children is, how can we engage students in activities that will promote the development of figurative counting while avoiding the trap of showing students how to count hidden items? Remember, Steffi's stages identify shifts in a student's conceptual understanding. We want to facilitate the shift to figurative counting without directly telling the child how to do the math. I would like to introduce what I call figurative counting cards. A set of these cards consists of multiple copies of a card that has a countable feature. We have 3 examples of figurative counting sets here. The set could be cards with socks, or cards with 3-eyed aliens, or cards with 4-legged animals. Figurative counting cards is a great activity to do in small groups or with one student at a time. To choose students for this activity, you would think about children who have demonstrated that they have developed robust perceptual counting. To introduce an activity that uses the cards, you would begin by showing your students one card and asking them how many eyes are on the alien. Then you can turn the card face down and place 2 more cards beside it and ask the child, how many eyes are there altogether? Students may think that you have gone a little mad, but you can persist, asking, do you think you can figure out how many eyes there are? It is not uncommon for students who have not worked in this way before to simply count the cards and say that there are 3 eyes. Another approach that you might see is a student who slowly passes their finger across the cards while saying a counting sequence, often ending at 10. You will want to accept all attempts that students make and resist the temptation to quiz them about whether their solution makes sense. Keep in mind that it is likely that for many students, this entire activity doesn't make sense at first. Once the student has given their answer, you can turn the cards over and ask them to check their solutions. How many eyes do you see? At this point, students become engaged when they count the eyes and realize that there are 9 and that somehow what they did to solve the problem didn't make sense. They are eager to take another try at one of these strange tasks. On the second or third task, you will notice them trying to see in their mind's eye what is on the face down cards. This is exactly what figurative counting is, being able to imagine objects that you are counting without seeing them. For the second task, you could present an easier problem by asking the student to count the legs on the aliens. Turn the card face down and place out 3 more cards. And this time, they only have to count 2 things on each card. If you want to make the task a little harder, you could continue counting the eyes and add an additional card. This session includes a copy master for 3 different sets of cards. The socks are a great representation of 2 countable objects. The dog can be used to count sets of 4 legs or sets of 2 ears. You may want to create your own figurative counting cards. Any image with clear countable components that can be imagined when the card is face down will work. The goal is to provide students with opportunities to develop the habit of imagining rather than seeing the collections that they are counting. To summarize the big idea in this presentation, once students can count visible collections, the next stage of conceptual understanding is figurative counting, being able to count the socks on the cards even though they cannot see them. When we support this conceptual advancement with engaging, problem-based instruction, we help students stay on the sense-making pathway that makes math fun and exciting, even as it becomes more challenging. To wrap up this session, I would like to share some final thoughts. There is no script for the counting cards activity. When engaging students in these tasks, it is important to watch them as they work and to make decisions based on how they are making sense of counting the hidden items. The self-checking step in this activity is very important. It gives students a way to see for themselves whether their strategy was successful. It keeps math tethered to a concrete reality where things are supposed to make sense and where students become invested in figuring it out. This is a great mindset to develop as a young child. And finally, you may have students, even in kindergarten, who progress quickly to the concept of a numerical composite and demonstrate counting on, seemingly out of the blue. There is no need to provide these students with experiences to develop figurative counting. Conceptually, they have already moved on. I would like to invite you to attend a Zoom session to further discuss the figurative counting cards activity and to watch a short video of kinder students engaged in playing with the cards.